Well, there is a big sort of mismatch in terms of perception and reality when it comes to AI. I spent 25 years in the City of London, everything from quant trader, risk analyst, through portfolio manager, and I've even been global head of risk for a large investment manager. So I'm very good at looking at business problems, real world problems, and casting them in a mathematical framework and coming up with useful, usable solutions to those problems. But a good business leader, key decision makers, should be endeavoring to get the relevant information, to find the right people whereby they can implement a sensible AI strategy. What I say to people is don't be afraid, embrace it, use it, but be critical in terms of your use.
This week on GAEA Talks, Richard Saldanha. Good to have you here.
Hello, Graham. Delighted to be here.
So let's get straight into this. You've got a very business orientated, but with a touch of academic background. I think some very valuable experience. So why don't you give us a little background and let's get started.
Well, I hope so. Sort of potted history, the common link being my sort of mathematical background, in the library in South London, working through mathematics problems. And my view was that there's an inner truth to being a good mathematician. There's an ultimate proof or statement of fact if you can solve the problems. And then sort of in terms of sort of my business career, I spent 25 years in the City of London working as a quant. Everything from quant trader, risk analyst, through portfolio manager, and I've even been global head of risk for a large investment manager. And what I've did in throughout that career is I've basically tried to tie together mathematics, problem solving, and real world problems. So I'm not a deep theoretician, but I'm a pretty good applied guy. So I'm very good at looking at business problems, real world problems, and casting them in a mathematical framework and coming up with useful, usable solutions to those problems. And now what I'm talking about is essentially mathematical modeling. And to quote the famous aphorism from George Box, all models are wrong, but some are useful. And that's something that I basically keep close to my heart because I always assess whatever I produce through that lens. And then in terms of my academic training, don't need to go into huge detail, but basically I passed out of Oxford University, went to Oriel College, and I have a doctorate in DPhil from Oxford. That's Oxford University's name for the PhD in graph theory and multivariate statistics. Very much sort of applied area. And I have come almost full circle because I thought I was going to be an academic. Certainly my wife thought I was going to be an academic originally, but I went into the city. But I'm now in my 9th year of teaching at Queen Mary University of London. I'm a teaching fellow there, and I teach postgraduate level machine learning with applications in finance, essentially. So what I'm doing is I can teach what's in the textbook, and the real hook is that I then say to my students, and this is how I've used it in real life, and I give them, obviously somewhat stylized, but essentially we're looking at sort of real problems that I've encountered in finance and how I've gone about sort of solving them.
So that opens the door to, I think, a premise which is important to cover, which is that real world experience. And we were discussing before, so let's frame how we're going to talk about this bit. The age of this modern AI era actually applied, or the beginning of implementation within business, enterprise, finance of around 2 years, give or
Mm-hmm.
take. Arguable, but we're talking about actually getting into it. And then the world before, all of those topics and the expertise that you've been talking about, from statistical, from modeling, technology, machine learning, that world existed before, and then we've got this world now.
Mm-hmm.
What's your take on AI as perceived in the wider domain, but business today, and where's the gap?
Mm.
What's currently wrong with how it's looked at? Where are the
Yeah.
issues?
Well, there is a big sort of mismatch in terms of perception and reality when it comes to AI. In many ways, nothing much has changed. Why do I say that? I say that because we still live in a binary computing world. This is our most reliable form of computing. We don't have quantum computing as yet. That's a bit of a pipe dream. We have pseudo-quantum. We do have analog chips, but again, they are somewhat unreliable because they rely on solid state technology, or solid state components, as it were. And so you haven't got the sort of accuracy around it. So back to sort of binary computing, and it is phenomenal what we've been able to do with binary computing. And in effect, sort of what we have been doing for, well, many decades, well, almost forever. I mean, I could go back to the ancient Egyptians and the building of the pyramids and tell you that actually you needed calculus in order to build those pyramids. So we're talking about 2,700 years BCE. That's where it started, mathematics. We're back to, the ultimate truth in sort of mathematics. But I think there's an awful lot of hype, and there's an awful lot of sort of mystique around so-called AI. In my view, where we sit currently, things might change. There may be some major breakthroughs, etc. Where we sit currently, AI is one of two things today. It is either a large language model, which is essentially a neural network fit, massive neural network, billions of parameters, etc. It's a complete anathema to a statistician in the sense that we deal in parameters, magnitudes, and signs. You can't interpret billions of parameters. It was, for a lot of people, it was incredible anyone would even attempt to do that. But people have done that. Certainly, California, the big tech firms in California have put the resources into doing that, and I have to say that the output is quite phenomenal. So we have the sort of large language model fit, which is essentially a neural network on one side, or a set of neural networks, the transformer architecture, so on and so forth. We can come back to that. And on the other side, we have reinforcement learning, the sort of Richard Saldanha approach, where we have an environment and we have an agent, and an agent interacts with the environment and does certain things. And the solution to those types of problems is essentially a policy. So depending on the state of the environment and what the agent has observed, what's the optimum decision to make? Now, that sort of framework is best sort of understood in terms of playing a computer game. Think of a rudimentary, think of playing Mario Brothers, for example. I control the sprite on screen. What can I do? I can run, I can jump, I can crouch, I can go left, I can go right, etc. As I traverse the game, I'm in different states. Depending on the state I'm in, what's the optimum thing to do? And that's how you come up with the policy. And in a nutshell, that's essentially reinforcement learning. Mm-hmm. So where do these two things break down? Well, in terms of the large language model, this is probability and statistics writ large. It is a completely probabilistic system in terms of generating the next letter, word, sentence, paragraph, etc. It has no understanding of its own being. There's no consciousness there. There's absolutely no ghost in the machine. It is very clever in many respects. And the way I present it to my students is effectively modern day natural language processing. Natural language processing has been around for a long time. I was using a bag of word search to look at news in terms of stocks in 2004, not 2024. And then the reinforcement learning, the problem is that environment is not, it's very hard to describe a real world environment. So these things tend to be very stylized. So there is a mismatch there. And I'm involved in although it's largely dormant now, we might resurrect it. I'm involved in a reinforcement learning project at the Alan Turing Institute.
So in many ways, how LLMs currently work, like the equivalent of Milli Vanilli.
Mm-hmm. Yes.
And some people will have to Google that or Gemini it. But the idea is the thing that's being sold is actually a construct of something else, and it's not quite what it appears to be. Irrespective, it can have great utility, but that's when it comes to the form and the function in the real world. Given your background, let's look at the markets. So if we were to describe what the markets are on a global basis, even if you're sitting in a chair in an office in Mayfair or London or Manhattan, and you have a job, maybe your particular area is could be a particular commodity,
Mm-hmm.
it could be dollars, yen, it could be equities, it could be whatever it is.
Sure.
So you would have to then understand what data is there, what does good look like. You're effectively making money on a trade or losing money on a trade. How would you break down the component parts and begin to look at which parts of what is commonly understood as AI, or maybe not even AI, would fit into the different areas? So you could engineer and aggregate how the utilization of different forms of AI actually have utility and function within, let's say, the markets.
Yeah, I mean, that's sort of been my background. I mean, that's been sort of my bread and butter, and I've used various techniques in order to sort of tease out those different facets that you've outlined. The conclusion I came to after many years was that actually what you're trying to do is model human behavior, which is incredibly difficult to do in a real world scenario. And in terms of sort of trading activity, it is possible to build models. I've done it that are well calibrated, good from a risk management point of view, and make money. But there's a huge amount of noise around that. There's a huge amount of uncertainty. There isn't a one-to-one correspondence with, a good model and your ability to make money. Reason being, people can do some very strange things, and what we tend to be anchored in is the sort of typical behavior depending on what the sort of prevailing mood or the economic circumstances are. So, for example, in the event that there is a market correction, we assume that people will sort of rush to the US dollar. I mean, the US market, the US is sort of still the pump prime of the world economy. We tend to follow the S&P 500 in terms of markets. Is that always going to be the case? If that isn't the case, and you've just piled into the US dollar, you're going to come unstuck pretty quickly. Similarly, gold.
But is this a point then where, and I'm just trying to look at relatable use cases of where AI could be valuable there. So a couple of assumptions. One, things always stay the same, which we know they don't. What is the difference between one individual understanding a huge number of signals whilst retaining context and being able to do that once, given we exist within reality second by second by second? So what influences these factors? Could you look at geopolitics? I mean, a good example in my mind is Jim Simons and what he did with Renaissance Technologies.
Absolutely. And I've been to Rentec, by the way.
Have you? Very cool. I understand one of the things that he focused on, because he started later in life. What was it, his 40s, 46 or something?
Yeah, mathematician.
Yeah, so a mathematician, but he'd been working for some form of intelligence agency of sorts, which
that's correct.
I
yes.
believe he was asked to leave after sharing his opinion. But my understanding is one of his big focuses was the climate, environmental conditions. And if we're talking about human predictability, there are certain things that we do under certain conditions. We probably dress differently in summer on a warm day than we do in the winter. People perhaps behave a little differently if they're from freezing cold countries as opposed to baking hot countries. As the shift of things move and you get natural disasters, extreme climatic conditions, it's almost like a rabbit hole where you say, well, an example, the Fukushima incident. So was it a volcano, underwater volcano? Was it tectonic plate shift? Was it a tsunami? What's the actual cause consequence? Because it was a whole series of things. Now, as time went on, even as the tsunami took over that entire area, it was the microchips that were manufactured there. Usually, even in a tsunami, you could say, well, we'll rebuild. The second it goes nuclear and that water cooling tower exploded and the whole place goes a bit south, well, you're not rebuilding. But where did that sit in the global supply chain? What pressures did that cause? Who was using those chips? And I believe, I could be wrong, that it was Tesla.
Right.
Out of the 7,000 parts, or however many parts a Model S was, 3 came from there.
Okay.
But they weren't going to come from there anymore. So how long does it take? And then this rabbit hole of, well, it is in many ways predictable, but there are probably millions and millions and millions of use cases. That's a potential huge upside of AI, the ability to perform human-led, rational thinking and understanding of behavior on scale, and not necessarily on a probabilistic basis, but observing empirical data as it comes in.
Well, I have to take issue with you slightly. I mean, it is probabilistic. That type of event, the Fukushima event, was an extremely rare event. Now, if you're Nassim Taleb and you're running your options portfolio, that would be a deep out of the money put option that he might have had on, constructed in some way that would actually pay out if that event occurred. It's very hard to build that into a model that is involved in sort of day-to-day.
But that's what I'm saying. The observing of what has happened as opposed to predicting what may happen. But the time between something happening and the response, closing that down.
Yeah, I hear you, but the thing is, we and the quote unquote AI models are going to do exactly the same. They're going to look at what has happened historically and those characteristics, those factors, etc. What has been what have people done based on what has happened in the past, and the models that we want to use in a predictive manner, which is I think what you're suggesting, are really going to be based off that. They're still based off that history to a large extent, and so and in many ways, to sort of pull it back to where I started, we're not doing anything particularly different with AI than I'm glad you mentioned the late Jim Simons was doing with Rentec. I mean, he was ahead of the game because he had breadth in terms of models. He was very happy to look at a huge range of statistical models, perhaps most likely more than many other sort of quant investment firms were looking at. He also, I think, probably pioneered the use of alternative data. So you mentioned climate, but it wasn't just climate. It was sort of, remote sensing, satellite imagery, etc. The cars at Walmart, or using that input. Now those are those types of things have some correlation, but the effects tend to be weaker. But if you can combine them, we've got sort of model averaging, things like that. If you can combine them, then that can be a very powerful model. But the fact that he had that breadth in place, I think, is really what marked Medallion out. I think it compounded at over 40% on an annualized basis
for 20 years, isn't it?
Yeah, absolutely. And by the way, that another very sensible thing that Renaissance Technologies did was to limit the size of the fund. So it wasn't an LTCM.
They didn't
get carried away. Yeah.
And also, he would only employ people that specifically had not worked in the financial industry. My understanding from reading his book.
That's correct. So yes, to a large extent. And actually, if you, I had the privilege of going out there, it actually looks like a university. I mean, there's no, I asked about the trading floor, and they've got some guys who do some stub trading down there, but basically it just looks like a university department. Great long corridors with people's names on the door, and dismantled some workstations and bits and pieces all over the place. So.
But I think the value of that, and this is where I think the academic side to your experience in what you're doing is really important. The difference maker in many ways is the human being to look at things differently. And even if we're to put into context from a trading perspective, you could ask in the future AI to look at things, but based upon almost a scientific breakdown of what it is, statistical probability of the next word, the value comes from the individual, the instinct, the experience, having been through a crash and then having been through things.
Yeah.
At this point in time, in this modern revolution, and again, to give an idea and give value to the viewers who are decision makers across many different sectors, the value of a human to empower their ability to leverage AI requires education and requires an appreciation of what it is about humans that is valuable.
Yes, I agree with what you've just said to a large extent in that, and I'm not anti-AI. I tell people to if people are afraid of it, I say nothing to be afraid of. Embrace it, use it. These tools, and let's talk about sort of large language models. They're based off what I have to do is I have to get input data. So a corpus, a body of knowledge, which I have to encode. I have to turn those data, or I have to turn it into data. It can come in many forms. It could be images, it could be text, etc. I have to turn it into numbers. Ultimately, I have to turn it into binary, zeros and ones. We talk about tokenization. So that is basically the translation of our text, images, etc. into zeros and ones. The output is affected by what we do at that layer. And the next thing we do is we fit a model. We fit our massive neural network, our attention mechanism, and we use that in order to generate the output. Now, if you are a subject matter expert, and I think this is true for every single subject matter expert I've spoken to, doesn't matter whether it's sort of medieval history or physics. When they've interrogated these models, even today, the output is not bad, but it's very bland. Doesn't give you all the detail. Okay. However, is it useful? Very often, yes. I personally use it as a filler. For example, I might be describing some sort of method. There might be some ancillary element to that. I need to unpack that a little more. I will use a large language model in order to do that. And I have my training as my anchor, because I can say, oh, actually, that's good, or that's sort of vaguely reasonable, or actually that's completely wrong. That doesn't make any sense whatsoever. So I think these things can be really useful in the right hands. So It is merely another tool. So, a chisel in the hands of an unskilled carpenter, probably not that useful.
What negative consequence, I don't want to sound too negative, but the point that you've just said there, and this resonates with a lot of the guests from many walks of life that we've had. How do you deal with circumstances where it is very important to understand from that anchor point what good looks like and bad looks like? If you don't have the anchor point, we now have a lot of people.
Yeah.
We've got the generational thing, but we've also got people in businesses. And the is AI going to take my jobs rhetoric. If the people making decisions in different business functions don't understand the fundamentals of what you've just said, or can't leverage against a good anchor point to say, well, it may look good on the surface, we can reduce headcount or we'll get better results.
Sure.
Maybe they're being pressured to adopt. Taking all of the things into consideration with some of the very large companies pushing to sell the product that they have, very little of that in reality has any compounding effect or any relationship with reality of what are you there for? What experience do you have? What are you trying to achieve? Where are things going? What does a good decision look like? So it comes into leadership, it comes into leveraging subject matter expertise. Do you have the subject matter expertise in the right position? It's like we've got a bus driver that doesn't know how to drive. Doesn't make sense, but he's a bus expert. But you replace AI with any particular word, it's almost like an excuse to make decisions, to hide, or to just do things for an ulterior motive, or just out of the fear of not wanting to lose your job. So you adopt something, but you don't know how to use it. And when you get down to the basics, go, particular things, even how some of these LLMs are used, are not the right tool for the job. They're chisels when you need hammers. How does a business leader or anyone within a business function think about that? How should they think about that?
Well, there's a lot there that you've sort of put up. But a good business leader, key decision makers, should be endeavoring to get the relevant information, to find the right people, whereby they can implement a sensible AI strategy. And by the way, AI strategy seems to have sort of replaced digital strategy. One of my favorite questions to CEOs historically, when they said, we need a digital strategy, what do you mean? And very often they couldn't actually articulate what they meant by it. So I think it's about people being honest with themselves. And there are people out there with the knowledge, with the training, and plenty of engineers, physicists, mathematicians, statisticians, etc., who are often very quiet. Actually, I think they could be more vocal about their subjects and about their knowledge, and could provide very valuable help and advice to firms. You mean, coming back to what I was talking about earlier in terms of basic, data-based models. I probably prefer the moniker IA, intelligent automation. And what I saw in the financial markets, in terms of how firms were run, was a huge amount of inefficiency. There were some very mundane tasks that were repeated on a daily basis by human beings. Well, that's ripe for automation. So that's where firms should be looking first, rather than saying, oh well, let's get an LLM in and we'll use that to produce all our market commentary, for example, or put an AI in to sort of in the middle of our sort of data chain. Because I mean that's that sort of latter example is hugely disruptive. You really need to understand what's in place. And by the way, if this thing has been working for many years, it's likely it's pretty good. You don't need necessarily an AI component. So it's all about clarity, thinking clearly, having the understanding to sort of implement things correctly, and sort of having being humble about one's own knowledge. It's difficult.
Well, you mentioned in our little pre-chat a circumstance with cars.
Yes.
Are you happy to?
Yes. I mean that's public knowledge.
Because I thought that was a really good way of addressing how people can potentially should think about things, the association between cause and effect, because it does seem there's a compression and perhaps deletion in many ways of the understanding of the potential consequence to an action. So run through that.
Well, I'll run through that example. So these were the cruise taxis that sort of ran in California, and as part of GM. And now that they're sort of, I'm not quite sure what the state of play is, but Cruise no longer exists as a company. And by the way, full credit to Mary L. Cummings, who is a professor at George Mason University in the States, and because I had the pleasure of meeting her at the RAC just before Christmas, and she sort of outlined this scenario. And basically, you have a self-driving taxi at a crossing. This is a true story, and you've got the taxi, and you've got another vehicle, pickup truck. To the left, you've got 2 lanes of traffic going in one direction and 2 lanes coming back the other way. And so the lights go green for the vehicles here on the right-hand side, and they proceed towards a crossing. And there is an individual who decides to cross when they, it was don't walk, they shouldn't have crossed, but they started crossing. The AI, the cruise taxi, basically determines that actually at the speed, the predicted speed of the pedestrian, they would be clear of their path by the time they reached the crossing. In fact, there was plenty of slack in the system from that point of view, in the sense that the cruise vehicle actually speeded up towards the crossing, which actually contravenes the California Highway Code, because if there is a pedestrian on the crossing, you don't speed up, you're meant to slow down. The cruise vehicle was quite smart in also registering that there was another vehicle to its left, and so the scenario sort of so the scenario proceeds. The pedestrian actually gets to the middle of the junction quite safely, but notes then that there's a lot of traffic coming in the other direction, and decides to, I think this was a redactive from the legal proceedings, but probably starts to go back to where she came from. At which point this unfortunate woman spots the pickup truck bearing down on her, driven by a human, by the way. Pickup truck doesn't slow. In fact, collides with her. It's a side glance, and basically knocks her into the path of the cruise taxi, that hits her at just over 20 miles an hour on the crossing. I believe the pickup truck was stolen, and it's sort of clear sort of hit and run. So poor pedestrian is injured, but would probably be in reasonable shape at this point. So hits the bonnet of the cruise vehicle, ends up on the deck, at which point the cruise vehicle no longer registers a human being, but has registered that there had been a collision, and so has stopped, did brake, has stopped, etc. And what it then does is, because these vehicles have been responsible for blocking roads when they're uncertain about what to do. It was programmed in the event of a collision, and specifically a side collision, which somehow this that's what got triggered. To move to the side of the road. So the fact that it couldn't see anybody in front of them, is actually on the deck. There are no cameras on the underside of the car, and the fact that it somehow had registered it as a side collision as opposed to a front impact collision, it then proceeded to move to the curb, dragging this poor unfortunate person underneath the wheels, and was caught on the rear right hand side, rear right hand wheel. Gets dragged to the curb. In fact, the maneuver doesn't get completed fully because it fails to get traction at some point, registers that. Reason being that it's on this poor woman's leg, and so the wheel is just spinning against her leg. So this poor woman spent over a year in hospital, being undergoing rehabilitation. So she did survive. But I mean, this is a combination of, is AI? I mean, this is pure. I mean, this is poor human decision making, encapsulated in a computer code. And by the way, Cruise was meant to have a stop button. Because what isn't broadcast is the fact that these self-driving taxis all have control rooms. So think of flight controllers. It's the same sort of idea, who are monitoring what goes on. Now, this thing happened relatively quickly, and it was observed by the humans in the control center. Now, because of cost, the stop button, the hit the button, stop everything, wasn't implemented. And so, it's this combination of factors led to this sort of horrible situation that we observe. And the sort of argument that actually we're saving money by not having a driver in the cab. All we're doing is we're replacing that human being with somebody in a control room. Oh, maybe we need far fewer humans in the control room, but don't be fooled that these self-driving taxis are completely autonomous. What they typically do is they stop. They're uncertain. They don't know what to do. And that's a good fail-safe. But the problem is you then need to sort of clear the road. And so that's where the sort of control room takes over. And if you're lucky, you've got perhaps a reasonable Wi-Fi connection to the car. If you're unlucky, you're doing it over a mobile phone network with the added latency. And so I'm sure you can realize the risk or appreciate the risk involved in trying to, move a car using, over a mobile phone network.
I mean, that's one of the issues with scaling out remote robotic surgery. The latency, I think it's something like absolute tops 20 miles from point to point where the surgery is happening. I know it was looked at surgeons in the UK and the US doing remote surgery in war zones across the world. You can have some remote functionality, but the latency, what is it, like 76 milliseconds or something of that nature between London
That's a lot.
and New York. I mean, that could be problematic. But I think the example that you kindly gave there highlights the legal, regulatory, the compliance, the ethical. There are so many factors in and around that. And I'm always just concerned that unless you have either the right thinking to get the right form of, again, whatever's called AI, utilized in the right function, that there is enough time to have considered what the consequences are, that the rate of adoption of inappropriate AI, where we are absolutely aware it's not auditable, it's not trust and truth based. It is subjective black box technology. And the data is put in the wrong place and the utility is leveraged out of the wrong place without, as I say, the time to think and consider. The equivalent of what you've just talked about there is probably inevitable to happen again and again, but on a much bigger scale, more and more and more. But what's that going to look like? Because if companies have implemented technology where they haven't seen or considered the consequence because they've adopted this within the last 18 months or been part of the process of rolling that out and haven't taken consideration, haven't had understanding, haven't really looked at all the potential or potentialities, the next year to two could come with some terrible surprises.
Well, I mean, it could. I mean, it is well, a couple of things there. I mean, what I've sort of outlined essentially is, and it is computer programming, is implementation. Is the implementation appropriate, as it were? We can call it AI, but essentially it needs to, it's code in some form. So it's a neural network that's basically taking real world images and turning them into pixels. Again, zeros and ones. How do I interpret those zeros and ones? What's sort of going on there? And I would suggest that the sort of cruise example that I outlined, yeah, okay, we can call it an AI, but it is a lot of it sort of programmer error.
But that's a really important point to the audience, because the narrative in the primary public domain is AI is a thing. It's not a thing. Infrastructure is a thing. Security, data sovereignty is a thing. Machine learning, various iterations are a thing. Graph-based technology is a thing. Databases are a thing. Algorithms are a thing. The concept of AI is an orchestration of multiple different systems, approaches, information, aggregated and assembled together. And of course, then it's the use case. What utility does it have? What context does it sit? Unless all of those things are considered, assembled, and understood, then to say implement AI, the audience really, hopefully, can see doesn't mean anything. That's a sales tactic. It should be revealed underneath. And
I agree wholeheartedly with everything you said, and that's what I've sort of tried to outline. That you've got these building blocks. You've got the sort of pattern recognition and the neural network, and you've got the sort of decision making, which is encoded in terms of rules. All these things come together to effectively create the quote unquote AI. But to sort of put a positive spin on things, we can create really good systems. So, for example, planes effectively fly by wire. They've been flying by wire for many, many years, and very safely. I know that, when it goes wrong, it's disastrous. But in general, it's a very safe mode of transport. We're able to do that. We've been relying on sort of fuzzy logic in order to sort of handle that. We fly helicopters using fuzzy logic. Another branch of mathematics, etc. If we can do that, there's no reason why we can't create sort of safe self-driving cars. It's where, it is having an understanding of all those different facets that go into creating a safe sort of self-driving car, and also not being willing to sort of spend money on the relevant technology. So I don't want just to rely on cameras and a neural network. I might like radar, and I might also like LiDAR. Well, that has suddenly become a very expensive system in order to implement. And I probably do want the human in loop as well. So I do probably want skilled people in the control room. And actually, I don't want you to cut corners. I do want the off button. I do want you to be able to sort of hit the off button if something disastrous happens.
Yeah, it makes sense. And the education part there, it's not always having a PhD in something. It's just basic understanding. So it's almost countering the, we're selling this one product, buy it, it'll solve everything. What is the Silicon Valley, trust me, bro,
Yes.
approach. You can look under the hood and say, right, now, what are you trying to achieve? Well, we don't need that. This works really well. That's tried and tested. This novel new way could actually provide massive utility from the perspective of the individual user. It could be the user, it could be the company trying to empower their people. It could be how we use it in our personal daily life. I mean, the use of Gemini, it would seems to have come on a huge long way.
I use Gemini.
Yeah, I think it's brilliant having that dual thought, the ability to question and spark a thought and then go backwards and forwards. And there is massive, almost augmented human capability, which of course nobody wants to really do mundane, boring things, which their time could be better served elsewhere. I think Oliver Patel had said the banal things which are neither good nor bad, but just need to be done, but there's no inherent additional value in doing so. Compress those down.
Sure.
But it's choosing the battles and saying anything which could potentially be fantastically great or of massive risk, consider those factors. So tell me about your involvement with the Institute of Science and Technology.
Well, that is about helping the wider public, well, aimed really at institutions, but helping companies to sort of understand what's under the hood. And so we have a range of courses. We have intermediate concepts in artificial intelligence, which basically takes these sort of mathematical building blocks and puts them in context. It explains them, puts them in context. These are technical courses. We've got one on deep learning. We've got another on large language models. And so companies who want to sort of find out about these things, want to educate their staff, can come to the Institute of Science and Technology and learn about them. We are a very nimble, respected professional body, been around for 78 years. Our president is Helen Sharman, Britain's first astronaut.
I mean, that's an exact valuable thing for, again, our audience, business users, people with technical responsibility who perhaps are more traditional that want to understand, well, how can we think about this? The more of this type of thing, the better, I think.
So taught by people who are sort of hybrids. So I'm obviously one of the teachers. So academic training, but plus real world experience in a commercial setting,
which is really needed, because all academic leads to one direction, all business leads to another direction. We need to have the blend of the two.
Sure, there are lots of people out there who have bridged the divide, as it were. But and they're not a huge number, and they are very sought after.
But I think the statistical probability of the amount of businesses and people that have that as a requirement is probably fundamentally 10x to 100x, 1000x since 2 years ago. So
absolutely, yes.
So what other final thoughts do you have?
Well, I think as I sort of suggested earlier, is absolutely don't be afraid of. I mean, I hear a lot of sort of fear, and there is a lot of fear mongering that people say, this thing is suddenly going to become conscious, it's going to take over the world, and it will dispense with all human beings, etc. The Terminator sort of scenario. Actually, no, we don't. The technology is not mature enough of a type that could conceivably happen. There's no ghost in the machine. There's no sudden spark. Can human beings do stupid things with the technology? Absolutely. And in fact, I mean, decades ago, we could put a pattern recognition system on the end of some sort of missile defense infrastructure and wreak havoc. So, I mean, we've had the tools for an awful long time. What I say to people is, don't be afraid, embrace it, use it, but be critical in terms of your use. You mentioned Gemini. We shouldn't focus on one particular large language model, but I use these things all the time. So, for example, I had to have a legal agreement drawn up. I actually took some legal agreements that I've used historically. I gave them to Gemini, and I told Gemini that I needed something for a particular client in a particular context. It did a really good job. That document did go to my lawyer. I didn't dispense with my lawyer. They actually did review the document, and there were a couple of things that they sort of pointed out that the large language model hadn't appreciated or had overlooked, etc. And so it was very valuable. But actually, the document review process, that iterative process that I would typically undergo, was massively shortened by the use of Gemini there.
If you put that together, that is a perfect example of how to create additional value, not to replace, but to generate greater value quicker, whilst respecting a structure and a framework of what is right, trusted, delivers a result.
Yeah, absolutely.
So, Richard, it's been an absolute pleasure having you on, and look forward to seeing you again.
Graham, thank you very much.
Thank you.